What's up, guys? My name is Michael and welcome to my YouTube channel. So today we're going to talk about managing arrays and strings. So on the previous day we learned about integers, characters, and other objects. Like, remember, integer is just like a number, floats are just like decimal numbers, objects are stuff that you could create, and then characters are character like an X, Y, Z, W, whatever it is on the keyboard. Now we're going to learn about what arrays are, how to define them, what strings are, how to use character arrays to make them, relationship between arrays and pointers, how to use pointer arithmetic, and what linked lists are. So what is an array? An array is a sequence of data, collections, of locations where each of which hold the same type of data. So basically each location is called the element of an array. So basically it's just a list of numbers or a list of whatever type it is. So when you declare an array, you write it by having the type, then followed by the array name, and then the subscript. The subscript is the number of elements in the array. So like the number of elements, as in like how many items are inside the array. What I mean by that is like the size of the array, basically. It's surrounded by square brackets, for example. Long array. Basically, long array, 25 means that it declares an array of 25 long integers named long array. So remember, long is just a longer variation of an integer type, right? So an integer is just a random number, but long is like it could hold long numbers, very long numbers. So when the compiler sees this declaration, it sets aside enough memory to hold all 25 elements. So when you do long array, 25, it holds enough memory to hold all 25 elements of the array. So each long integer contains 4 bytes, and this declaration sets 100 continuous bytes of memory. So yeah, that's because 4 times 25 is 100. And because each integer contains 4 bytes, this declaration sets 100 continuous bytes of memory, as illustrated here. So now we're going to access array elements. So how do we do that? We access an array element by referring to its offset from the beginning of the array. So an array element offsets are counted from 0. Therefore, the first array element is referred to as array name 0. So in the long array example, array 0 is the first array element, and then 1 and so forth. And then that means that it ends at 24. That's what it means. So basically, long array 25 means it starts at 0, okay? All arrays start at subscript 0, and it ends at 24. Not at 24. 25 minus 1, which is 24. So basically, all arrays start at to index an array, it starts at the 0th element, okay, and then it ends at whatever the length minus 1. So basically, this has 25, so that's why it's the length minus 1. 25 minus 1 is just 24. That's why it's 24, basically. So to access them, they all start from 0, and therefore the first element array is referred to as the array name 0. Then in the long example, array name 0 is the first element array, and then array name 1 is actually the second, and then so forth. This can be confusing, and the array 3 has 3 elements. They are 0, 1, and 2. Okay, to access. So if you create like an array of 3 elements, to access the first element, that's the 0th position. To access the second element is at the first position, and to access the second element is at the third. To access the third position is at the second position. To access the third element is at the second position. I mean, is the n minus 2, n minus 1. That's why. 3 minus 1, which is 2, because some array n has n elements that are numbered some array 0 through n minus 1. So that's what arrays are. So remember that this is because the index is an offset, so that the first array element is 0 location from the beginning array, the second is the first, and so on. So therefore, array 25 is numbered from 0 through 24. So that's what it means. So based on this example, I'm not going to type this up, but they create an array of 5 elements, right? 5 integers with the 5 subscripts to the brackets and then a 5. Then they created an I for the index. They loop through 0 to 5, right? So the last one is the 4th one, okay? So they print out 0, 1, 2, 3, 4, okay? So then they print out, okay, the value of I, and then they see in. That means they read in the element from the keyboard, what value you want, and then they print out all the elements of I. Because the reason why we do 0 to 5 is because it goes from 0, then it's I is 0, right? Then it does this thing, then it checks, okay, then it adds 1, then it checks, is I less than 5, which is 1. After it adds 1, it's 1, right? Is 1 less than 5? Yes. So it does this again, and it keeps throwing it. But when it goes to 4, right, it adds 1, then is 5 less than 5? No, so then it doesn't do anything anymore. So that's why it goes from 0, 1, 2, 3, 4. Okay, that's why this for loop does 0, 1, 2, 3, 4. And when you print out all the elements is 0, 1, 2. The index is at 0, then 1, then 2, then 3, then 4. And that prints out all the elements of your array. So when this does that, the for loop is say to, yeah, so each element has access. Okay, so writing past the end of an array. When you write an element, an array, the compiler computes where to store that element based on the size of the element subscript. Suppose you are asked to write over the value at long array 5, which is the 6th element. So what would the compiler do? The compiler multiplies this offset 5 by the size of the array, in this case 4 bytes, and then moves that many bytes from the beginning array and writes a new value at that location. So if you ask to write the value at 50, most compilers will ignore the fact that no such element exists. Rather, the compiler computes how far past the first element it should look, 200, and then writes over whatever it is at that location. This can be virtually any data, and writing your new data, there will be unpredictable results. So if you create an array of size 4, okay, let's say in this case, you create an array of size 5, right? But then you write at the 50th element. There's the length is 5, right? But if it's the 50th element, you don't know what could happen at that time. It's unpredictable because the compiler tries to compute how far the first element is and then writes over whatever is at that location. So if it's 50, it doesn't know the size, it's not going to give you an error. So that it could have unpredictable results. If you're lucky, your program will crash. If you're unlucky, you'll get strange results later in the program, and then you have trouble finding out what went wrong. So compiler is like a blind man pacing from off the distance from a house. He starts at the first house, Main Street 0, and when you ask him to go to the 6th house, he says to some, I must go 5 more houses. So each house is 4 big paces. I must go an additional 20 steps. If you ask him to go to the Main Street 100, the Main Street is 25 houses long. He paces 400 steps. As long as he gets there, he will no doubt step in front of a truck. So be careful where you send him. Okay, yeah. So in this example, he writes past an array. You should compile this to listen to what error message you get. Okay, so here I'm not sure if I want to compile this. This is just really long code. Okay, so they created an array of 3 elements. That's long, integer, right? And then an array of 25 elements, that's long, and an array of 3 elements, and then it's also long. They loop through 0 to 3, right? And then they set all the first array, all the values from 0 to 3, which is like not including 3 though. So like 0, 1, 2, they set all of them to 0. So the first array has all values. 0 to 2 have 0. The second array has 0 to 2 has 0, right? Then it prints up, goes through all the values of 0 to 24, right? To fill up the values in the target array, right? So then they loop through everything and then sets them to 10. Then after that, they print out the current value at each end location, okay? Then they print out from 0 to 3 each value of each location, right? Then they assign, this time they go past the array and see what happens. So they set it to 20, and then they print it out. So let's see what happens. So, okay, for their output, they actually got, yeah, okay. So the arrays were initialized with value 0 because we declared if memory is over and beyond the is that likely as a change rather than some unknown area of data. Some compilers could count down in memory, others count up. For this reason, the sentinels are placed both before and after a target array. So this confirms the sentinel values are okay to print them as well from the first to the last array. So they are all reassigned to the initial value of 10 and then a new value of 20. However, counts the offset, which doesn't include this. So it prints out the... Okay, so it's pretty happy to print out 20. So it actually worked for them. However, when they print out the value of 0 and 1 again, print out the value for 0 and 1, it reveals that their memory changed because they went past the array length, right? So in this thing, they rewritten the value at 25, even though the length of the array is 25. So the last element should be 24, but they did 25, and that actually changed. It worked for them, right? There was no crashing, nothing crashed, but it actually changed their first elements. Their first elements were changed to 0, which is not good. Even though it was accessed, they actually accessed the first element. It went past and went back to the first element, so that's not good. So that's why don't go past your array length. This bug can be very hard to find because 0's value was changed in part of a code, and that was not writing to the Sentinel 1 at all. Fencepost errors. So it is common to write past the end of the array, but this bug has its own name. It is called the fencepost error. This refers to the problem in counting how many fence posts you need for a 10-foot fence if you need one post for every foot. Most people answer 10, but of course you need 11. Okay, yeah. This type of off by one error is a bane of every C++ life. However, you'll get used to the idea that a 25th element counts only to element 24 and everything counts from 0. So yeah, that was pretty much it. So how can you initialize arrays? Well, you could initialize them with the closing braces as well. So you could do int integer array 5 and then have 5 numbers and initialize them in these closing braces, opening closing braces, and then remember to put a semicolon. So this declares the integer array to have the array of 5 elements, 5 integers, right? And it assigns 0 to the value 10. So 0 to the value 10, 1 to the value 20, 2 to the value 30, 3 to the value 40, 4 to the value 50. So that's what it does. You cannot initialize more elements than you declare for the array. So if you do int array of length 5 and you do 6 elements, it actually generates a compile error because you declared 5 elements and initialized 6 values. It is legal however, to write 5 elements and then only initialize 2 values. In this case, you declared a 5 element array, only the first 2 elements, 0 and 1. Okay, so yeah, so you only initialize the first 2 elements, 0 and 1. Do remember, let the compiler set the size of initialized arrays. Do remember that the first element of array is at 0. Don't write past the end of the array, and don't get goofy with array names. So just FYI, in C, this would actually initialize the rest of the 3 values to 0. I'm not sure what they do in C++, but I'll just see what that does. But it might differ for each compiler. It probably will print out garbage for the last 3 values, but I'm not sure. So I'm going to type it up and see what it does. So I initialized an array of 5. No, I created an array. I declared an array of 5 elements, and I initialized the first 2 values to 1 and 2. And then I printed out all of them, all the 5 values, right? And let's see what happens. So they actually initialized the rest of the values to 0. Okay, so if you created an array of size 5, right, and then you initialize only 2 values, the first 2, 0, the first value at the index 0 to have the value 1, and then the second value at the index 1 to have the value 2, it actually initializes the rest of 3 and 4, and 5 to have all zeros. That's what it does, okay? So anyway, let's just go back to declaring arrays. Now, let's go back to here. Declaring arrays. So this code uses magic numbers for it's easier to use constants to allocate these arrays. So arrays can have any legal variable name, but they cannot have the same name as another variable name or array within their scope. Therefore, you cannot have an array named myCats and another name myCats at the same time. Okay, that makes sense. In addition, when you declare a number of elements in addition to using literals, you can use a constant or enumeration. Yes, okay, it is actually better to use these rather than a literal name because it gives you a single location to control the number of elements. Okay, yeah, that makes sense. Okay, if you want to change the target array so that it holds 20 elements instead of 25, you have to change several lines of code. So if you use a constant, you can change the value of your constant. Okay, so all they did was they used the constant so that they could change the value of the constant. So here they declared an array of days in a week, right, which is 7. Currently, 1, 2, 3, 4, 5, 6, 7. Yeah, but here it's 0, 1, 2, 3, 4, 5, 6, 7. Yeah, 7. Okay, say days of week 7, and then they have they declared a 7 and they initialized these values. So then that way, if they want to change the size and later on, they could just change the size of days in a week, the variable days in a week. They could just change that variable name, that constant, to whatever they want, and then this size of the array would change when they declare it. So here they said days in a week is equal to 7, and then days a week declared have 7. So if they want to change to like days a week to have 100, they could just do that. So then they could just change the size of the array week instead of doing that over and over again to replace the value to 7 that has 7 to size of 7 to 8 or 9 or 10. They could just change days in the week to 10 or whatever so that they would have 10 values instead. Okay, so they could declare 10 values. Okay, so we're going to talk about using arrays of objects. Any object built in or user-defined can be stored in an array. When you declare the array to hold objects, you tell the compiler the type of object to store and the number of which to allocate to the room. So the compiler knows how much room it is needed for it based on the class declaration. The class must have a default constructor that takes no argument so that objects can be created when the array is defined. So accessing member data in an array of objects is a two-step process. You identify the member of the array by using the index operator, and then you add the dot to access each member. So this here illustrates how you could access an array of 5 cats. So what they did was they created 5 cats, right? And then in each cat at I, they loop through each cat to 0 to the end, the length, which is 5, right? So that goes 0, 1, 2, 3, 4. Because 4 is the last element, at index 4 is the last element, they did 0 to loop from 0 to 5, right? And then for each object in the array of cats, they set the age to 2 times I plus 1. So that's basically is at 2 times I is at 0 plus 1, so it's 1, and then 2 times 1, which is 2 plus 1 is 3, and then it goes so on and so forth. And then they printed out the age at each location, each cat object, right? That each cat object has. So that's 1, 3, 5, 7, 9. So here to declare the class object, the class must have a default constructor so the array objects can be created in an array. So in this case, the default constructor is declared and is declared in line 8. Okay, so yeah, it needs a default constructor. Okay, so in this case, they must have a default constructor so that objects can be created in an array. In this case, the default constructor is for each cat, a default age of 1 is set as well as the default age of 5. Remember that if you create any other constructor, the compiler supplies the default constructor is not needed, so you must create your own. So the first for loop, it sets each value of 5, and yeah, so we know that. Okay, so you could also declare multiple dimensions array. It is possible to have arrays more than one dimension, and each dimension is represented by a substring of an array. So yeah, it's the same thing. Basically, a array of 2-dimensional arrays is just, it's like a board, okay? It's like a board, a chessboard. So like but it's by row by column, okay? So like at element 0, so this would be, it would be 0, 1, 2, 3, 4, 5, 6, 7, and it would be row by column, and the column would be 0, 1, 2, 3, 4, 5, 6, 7. Okay, if you declare an array of 8 by 8, right? So the indexes are 0, 1, 2, 3, 4, 5, 6, 7, and then the columns are 0, 1, 2, 3, 4, 5, 6, 7, right? So for row, if I want to have the value at here, this is a bad picture, but whatever, it would be 5, 5, right? Here would be, because it's 0, 1, 2, 3, 4, 5 here, and then 0, 1, 2, 3, 4 here. Actually, it would be, yeah, okay. That's what it would be. So suppose you create a class of square, and the declaration of an array named board, represent it would be here. Is a square board 8, 8. You could represent the data with a one-dimensional 64 square array. So it would be square 64. So if you want to access the first row and then the fourth column, right? First row and fourth column, it would be 0, 3. Okay? Because if it's by row by column. So initializing multiple dimensional arrays. So you could initialize multiple dimension arrays. You could assign the list of values to array elements in order with the last array subscript. Changing each value as the former holds steady. Therefore, if you have an array of integer 5, 3, the first 3 elements go to array 0, and the next 3 in array 1, and so forth. Okay? So that's what happens. If you do array 5, 3, right? It's good. The first 3, you'll have an array, 3 elements in the array 0, 3 elements in array 1, 3 elements in array 2, 3 elements in array 3, 3 elements in array 4. Okay? Basically, a multiple dimension arrays is an array of arrays. That's what it is. Okay? It's like a chessboard. Okay, so here, maybe this will explain it better. So here we have a chessboard, right, of size 8. 8, right? So each array is 0. Each array, think about the rows, right? Rows, okay? Think about it like this: the 0th row has has eight elements, starting from index 0 to 7. The first row has 8 elements, 0 to 7. The second row has 8 elements, 0 to 7. And up to the 7th row has 8 elements indexed from 0 to 7. Okay? So when you declare multi-dimensional array, it's actually one array that has, it's an array that has an arrays. Okay? That's what it is. So if I declared an array 5, 3, I would have 3 elements in every single array of length 5. Okay? So it would have 5. Okay, so here I'll draw it out. If I have an array of 5 elements, 5, 3, right? Say array 5. That's bad drawing. Okay, whatever. 5, 3, right? So what does that mean? That means that first I have an array of 5 elements. Okay, so I'm going to declare an array of 5. Let's say, where's a rectangle? Where's a rectangle? Okay, I found a rectangle. Okay, so I declare an array of 5. Okay, so that means that here. Oh, I clicked the wrong one. Okay, so that means that there's 1, and I need to draw another one. 2, 3, 4. Okay, these aren't to scale. 5. Let's just like that. Okay, this isn't the. Normally they'll be even, but whatever. Okay, so then that means that it starts because I'm doing 5, 3, right? So I have 5 rows and 3 columns. That's what it means. Okay, so that means that I have an array of length 5, right? But it each has its own arrays. So that means I have an array of length 5 here, right? And then that means each has its own arrays. So that means I have another array. Here, I'll make it better if I draw it like this. Okay. So array of 5s, right? And then it start index at 0, 1, 2, 3, 4, right? But there's 5 elements, 1, 2, 3, 4, 5, right? Because array of 5, and then now it has 3. It has three columns, right? So that means that it's going to be a pointer to have 3 elements. My bad. 1, 2, 3. And this each has 0, 1, 2. That's what basically an array of arrays are. See? 0, 1, 2. 2. And then yada, yada, yada. Okay, so if I do index 0, first column, right? That would be 0, 1. Okay? And yeah, that's basically what arrays are. Array of arrays. So here, they initialize this array by writing int array 5, 3, right? So then they initialize all these values to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 15. So basically what this means is that they grouped everything into groups of 3s. So they did this int array 5, 3 equals a 1, 2. This basically means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. In groups of 3. From 0, 1, 2, 3. So basically, when I say int array 5, 3 has all these elements from 1 to 15, I create an array like this, right? But then they all have values 1, 2, 3, 4, 5, 6, and then yada, 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 7, 8, 9, and then they continue. That's what it means. Okay, let's go on. The compiler ignores the inner braces, but it makes it easier to understand how the numbers are distributed. So when you initialize arrays of an element, each value must be separated by a comma without regard to the braces. The entire initialization set must be within braces, and it must end with a semicolon. So yeah, that's basically it. So when you declare multi-dimensional arrays, you declare it like this. You could do it like this. So I'm going to have 2 elements, 2 rows, and then 5 columns each. Each have 5 columns. So they created, so that means there's 2 rows, 1, 2, And then there's 5 columns that have the values 0, 1, 2, 3, 4 in the first row, in the 0th row, right? And then they have the values 0, 2, 4, 6, 8 in the second row, but at index 1, okay? Because it's 0, 1, okay? So how do they print? Then they print out each value at each element. So what they do is you go through every single row. Well, there's 2 rows, right? There's 2 rows. So they loop from 0 to 2. So that goes through, it prints out all the values from values of the 0th row and then the first row, okay? And then they print out all the values from 0 to 5. So that prints out values from 0, 1, 2, 3, 4. That's what it does. So then they print out all the values. So you could think of it as 5 different dimension consists of 5 integers. Okay, so the values are based on 2, 7. Okay, so word about memory. When you declare an array, you tell the compiler exactly how many objects you expect to store in it. The compiler sets them down to size, but even if you never use it. This isn't a problem with arrays. We need to have a good idea how many objects you need. For example, chess 64. So if you don't know how many objects you need, however, you must use more advanced data structures. This book looks at arrays of pointers, arrays built on FreeStore, and various other collections, but you'll see that there are more advanced data structures if you don't know the size of how much you need. So, but you can learn more about the C++ if you look at linked lists. Okay, so building arrays of pointers. So basically, arrays discussed so far store all their members on the stack. Usually the stack member is more limited, whereas FreeStore memory is much larger. It is possible to declare each array on the FreeStore and then to store only a pointer to the object in the array. This dramatically reduces the amount of stack memory used. So they rewrite the array from listing 13.4 storing all the objects on the FreeStore. Okay, so all they did was they allocated memory on the FreeStore, right? So they had an array of a pointer to an array, right? An array of pointers has 500 cats, and then they had an index, and then they have pcat, right? It's a pointer to a cat. Okay, then they loop through every single object inside this family array, and then they they allocated memory on the heap for pcat for every single cat. Right? It's a pointer to a cat. Then they set each age of the cat, and then they set each array of pointers to point to that cat. So that's what they did. Okay, so yeah. So let's look at pointer arithmetic. So we talked about pointers, but it is worthwhile to cover pointer arithmetic. So there are a few things that could be done mathematically with pointers. Pointers can be subtracted from one another. A powerful technique is to point 2 pointers at different locations in the array and take their difference to see how many elements separate the 2 members. So this could be useful when you pass arrays of characters as illustrated here. So here they have an array of characters of size 255. Actually, 256 actually, because they added 1. Then they have of size 256, yeah. And then they have an offset starting at beginning. Okay, so then they read in the characters, enter a string, and then they read in the characters. Okay, so what they do here is this function parses words from a string. Okay, so they have a pointer to a character, which is a string, the string, right? Then they have the word and then the offset, a reference to the offset. So what do? Basically, the string is what is the string? The string is an array to is a pointer to the string is a pointer. Okay, so I don't like the way they did this. Okay, so what they did was they took an offset and they checked if it's at the end of the string, which is 0, and then they return false. Otherwise, they have two character pointers, and they set it equal to the next word, and then they go through every single. This is poorly written, but maybe they explain it better. Okay. Yeah, okay, whatever. So this program allows the user to enter in a sentence. The program then breaks out each word of the sentence. On line 15 is a prompt asking the user to enter a string. Okay, so we talked about that. So it returns array from the string until it reaches. Okay, so each call to get word causes a jump on line 26. So here's line 26, okay? So what do? Check is done to see if the value of the offset is 0. Okay? So what does this mean? This means that the offset is just the index, right? Basically, you could also treat pointers as arrays. It's very strange. Yes, it's very strange. But if you have a character pointer to the string, right? To the string, right? So basically what they did was, when you declare arrays, the first value is a pointer to the first value, okay? So here, I'll draw this out. I'm going to draw this out, okay? So here, they created an array of size 255. So let's just create, I'm going to draw the rectangle. All right, let's just assume you guys know that there's little boxes up to 255. I'm not drawing all 255 boxes. That takes way, way, way too long. But let's see how good I'm. Oh, yeah, okay. So, let's see, 1. And then, can I just control V? Whatever. Okay, so yeah, assume there's 255 boxes. So there are 255 of these, right? So when you actually pass it into a pointer, char star, right? A pointer is actually just the first element. You could treat everything arrays as pointers. So right, this would be the string. At 0. So this is the 0th element, right? And then this is 1. So when they passed it as a pointer, right? Char star is the string is a pointer. This is a char character pointer, right? So they passed in buffer into this character pointer, right? So this character pointer points to the first element of the string. Then they checked, okay, is this at the offset equal to 0? So this offset, what is offset? Well, word offset is basically it basically sees if it's at the end of the array. It's the index. Is this the end of the string, right? Because normally for arrays, when you create arrays, a string arrays, right? The last element is a null character. It's 0. So they check if this is the end of the string. The last character is 0, right? They check if the last character is 0. Then they return false. If it is the last, if it is 0, then they created 2 pointers, right? Character pointers. They set each value to the string plus a word offset. So the string is a pointer to the first element at 0. So when you add by the offset, let's say the word offset is 4, right? This is word offset is just an index. Add by 4, right? So then now P1 is going to point to the 4th value. Let me just delete this. Okay. So this is 0, right? 0, 1, then 2, whatever. Okay, so basically, remember, char the string, right? When you pass an array into, you could pass arrays to to pointers, right? If I have a character array buffer, right? I could pass that into a pointer, char the string. Could pass that as a pointer. So what does that do? They take the first element, the pointer points to the first element of the array for char whatever it is, right? So that's what this does. Okay, so now what here? Okay, I'll draw this better. Okay, instead of having these at the bottom, I'll draw it at the top. Okay, so this is 0, element 1, 2. Okay, and then yada 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 256. 255, yeah, 255 actually. Okay, so what does that do when you pass in an array into a pointer? If you pass an array as a pointer, here, the string, right? It would actually point the string to the first element of your array. So this array is called buffer, right? So this array is called buffer, B-U-F, right? If you pass this array into as a pointer called the string, they pass it in, right? What does that do? That sets the string, the character pointer, to point to the first element. What's the first element? 0. So now what do? They check, okay, word offset. This is basically just an index. What they did, they passed in word offset. They started at 0 at the beginning. They say, am I at the end of this string? So what is that? Pass in 0, right? They first pass in 0 here, right? And they say, is this the 0th element? Is this equal to 0? You know why? Because strings, the last element is always a null character, /0. So it always has a value 0. So that's why they check if it's 0. If it's the last element. If it is, they return false, right? Well, then what do? They created 2 pointers, P1, P2, right? So otherwise, this is not the last element. This is not the end of the string. So they created 2 pointers, P1, P2, right? So now I'm going to create P1, P2. Okay, now what do? Okay, now they all equal to the string plus word offset, right? So if it's not the end of the string, they take the string, this is the first element, right? Plus word offset. Well, what is word offset currently? Word offset is 0 at the beginning. Okay? So then what do? Plus word offset at 0, that's the plus 0, that's the current one. 0 plus 0 is 0, right? Because it's the start of it. So that means that P1 has whatever's at the memory address of this. So that's this. And then P2 also has the memory address of the first value element. So that's that. My bad if my drawing looks bad. But yeah. Then they eat leading spaces. They loop through the length of this whole string, and they check if it's a number. AL num. Where's AL num? I guess they don't tell us what it is. Okay. Then they keep adding the pointer P1. So what does that do? If this is a leading space, they keep adding 1. So okay, so let's say this is cat, right? Then they keep adding 1. If it's not is all num. Okay, this is a function call, passing in the string each character. This is in C++. This checks if a character is either a decimal digit or an uppercase or lowercase letter. That's what it does. So they check if it's a digit or uppercase or lowercase letter. They do that. Okay, that's what they do. Then they keep adding P1. So now if you have a word, that means that the first value at P1 is it's not a digit, right? Is all number, then they return false, right? So then they do the next one and they keep looping through that. And then they copy it into the character array, and then they create a null terminator, and they keep doing it again. So this just parses this allows you to enter a sentence, and then the program then breaks each word of the sentence, and it prompts them to enter a string. So that's what they did. I could explain this whole thing, what they're doing here. So they're basically skipping every single word, and then when they do that, like, because when you have a spaces, like this code appears to be in C++ report, what do? They mark it as a end of the word. So they have 2 pointers, one pointing at the start of the array. They keep going, and then once it hits, it's not a number, right? Once it is a number, they stop incrementing the first pointer, and then if you have a word at the pointer, like if it's not a number at the first, they return false. And then when they do the same thing to the second one, then they find the difference. They subtract the 2 pointers is a difference. So they have the length of the word. Then they copy, strn copy copies, it copies the number of characters into the buffer, which is an array. And then because arrays have last element a null character, they terminate it with the 0. Okay? Because string arrays have a string is basically an array of characters, right? With the last element null terminated. So that's what they did. And then they do that at the same thing, and they find the offset. Okay. So that's what they did. You don't have to know this code currently, but when we get more into pointers, you'll understand what this code means. Okay. So yeah, this is the pointer arithmetic is used here. Basically, you could add subtract a pointer from another one to determine the number of elements between 2 pointers. You could also increment a pointer, shifting it to the next element with an array rather than adding it by 1. This is very common. So what they mean by that is that, okay, so if I have a string cat, right? Okay, wait, hold up. If I have a string cat, right, and then I declare, and I pass it in as a pointer into, because arrays are also pointers, right? If I create a pointer called char the string that points to this cat, right? And then I create a second pointer that points to the area at the first one, then I subtract the 2. I could subtract these 2 pointers. So what do I mean by that? Okay, here I'll create the code for you right now, because I feel like you guys don't understand what I mean. If I create a string, actually for now let's say a character pointer. A character array is basically just a string. Okay, so character array of, I don't know, cat has size 4, right? And then I'm going to initialize them. Have C A T. Okay? The reason why I put size 4 is because I need to include the null character. So what C++ does is that the last in order for it to tell if it's the end of if it's the end of the string, they put a 0 at the end of the string. So that's why I need to have a null character 0 here. Because if I initialize this array with 4 elements and I have 3 elements, they automatically put the last element as 0. Okay, so that helps you determine. Okay, so now, what does this do? This created an array of size 3 cat, right? But then it also has a null terminator character at the end, right? And then let's say I create a pointer, char pointer p1. If I set it equal to cat, what does that do? That points it to the first element of the array of cat. So the P1 points to the first element of cat. All right, that's what it does. Now, if I set char P2 is now equal to cat at 1. Cat at 1, what is this? Oh, okay, yeah, I need it. The memory address of cat at 1. That's what it does. Okay, so if you don't put, you could set pointers to whatever is in an array. Okay, if you don't put the brackets, right, it automatically points it to the first element of the array, because arrays are pointers. Cat whatever is the pointer to the first element. Okay, so if I do char star p1, that actually equals the cat. That creates a pointer P1. And it sets it equal to the first value of my array cat. Right? Now if I create then P2, right, points it to the array value at 1, the memory address of the array value at 1, that's what it does. Okay? So P1 equals the cat. Cat is the memory address of, if you don't put any brackets, cat is the memory address of the first element. Okay? So that's what it does. The reason why we don't put ampersand is that because we're not actually, because cat is a memory address of the first element. That's why we could do that. If I do like the second element, like 1, then that's what it does. So what do I mean by pointer arithmetic? Well, I could actually do P1 plus plus. And what does that mean? That means that P1 now points to here. That's what it means. So if I print out the value of P1, star P1, value of P1, if I print out the value of P1 and the value of P2, remember, to find the data that I'm pointing to, I use star. It's going to have the same value, A. See? A. And why is that? Because they added 1 to the pointer. It now points to the first value. Okay? So I also could do pointer subtraction. So I could do P2 minus P1. And what does that do? Let's say I didn't add it, right? So now P1 still points to C. Let's say I didn't add by 1. So P1 still points to C, right? Because it's cat. If I do P2 minus P1, it tells me the amount of the position subtracted at this location in the array. So that would, what am I? I'm at the first element minus the 0th element. So that's going to give me 1. So you could subtract pointers like this. So if I do print out P2 minus P1, this time I'm not doing subtract P2 minus P1. So what am I doing? I'm not actually doing any subtraction. I'm not subtracting the data from each other. I'm subtracting the memory address of each pointer. So that's why I'm not using star. Okay, so I do P2, the memory address that I'm pointing to right here, minus the memory address I'm pointing to right here. So that actually subtracts the distance from each pointer, which is, for now, it's 1 minus 0, which is 1. It subtracts the positions of the array. So this is going to have the position 1. If you subtract these two pointers, it's going to print out 1. See? So that's what it does. Yeah, so you could add a pointer by constant, and you could subtract pointers. You cannot add pointers together because that just doesn't make sense. The reason why is that, see, P1 is a memory address of the character in the character array C, right? And A and T, right? If I add P1 plus P2, what is that going to give me? No, it's not going to give me anything. This is a memory address of 0 and 1, right? You add them together, it's going to give you nonsense. So you can't add pointers together. You can add numbers to pointers because that's just incrementing the position of the memory address. But you cannot add pointers together. So let's just try adding pointers together. See? It doesn't even it doesn't allow you to. Expression must have integral or unscoped enum type. So it must have if you want to add pointers, you have to add by numbers, because it tells you the number of positions you're adding. Because this is the memory address of the first element, right? And then this is the memory address of the second. So if you add them, you don't that does nonsense. It could point anywhere. It could point here or here. That's why. So yeah, that's what pointers are. So yeah. Declaring arrays on the free store. Okay, so they create an array and then 3 pointers and array names. In C++, an array name is a constant pointer to the first element array. So we talked about this. Therefore, in the declaration cat family 500, family is a pointer to the memory address of family at 0. Okay? This is the memory address of the first element of the array. So it is legal to use array names as constant pointers and vice versa. So if you do family plus 4 is a legitimate array of accessing the family at index 4. So why we talked about this, right? If I create a pointer, this is a pointer to the first element, right? Cat is a pointer to the first element. So if I do if I do cat plus 4, what is that pointer though? What does that point me to? Well, cat is a constant pointer to the first element, right? So if I add by 4, 1, 2, 3, null pointer, 4, I'm going to go out of bounds. So I shouldn't add by 4. If I add by 2, that's going to give me 1, 2. It's going to give me t. So if I print out the value of pointer 2, it's going to give me t. I use star to access the data that I'm pointing to. See? T. So yeah, it is legal to use array names as constant pointers. Therefore, a family plus 4 is a legitimate way of accessing the data at family 4. The compiler does all the arithmetic when you add to, increment, and decrement pointers. The address access when you add family plus 4 isn't 4 bytes past the family of object. It is 4 objects. It is an object of 4 bytes. Family plus 4 is 16 bytes past the start of array. If each object is a cat that has 4 long member variables of 4 bytes each and 2 short memory variables of 2 bytes each cat is 20 bytes, and family plus 4 is 80 bytes past the start of the array. So creating an array using new. So you could also create an array using new. Yeah, they created an array allocated memory for a pointer to a family, and they created 500. A pointer to an array of 500 cats. That's what it means. So it creates a pointer to an array of 500 cats. Because star equals new, an array of 500 cats. Okay, so that's what it does. And this is on the heap. You can see that pointer you declare is using the index operator. It's treated like a regular array. You can see that once. You could treat this pointer to the family array as an array name. The next one thing you will need to do it, however, is to free the memory you allocate it. Okay, so deleting arrays on free store. What happens to the memory allocated for these cat objects when the array is destroyed? Is there a chance of a memory leak? Well, if you delete the family returning from memory, if you use the delete with the array operator, deleting family automatically returns all the memory set aside for the array if you use the delete with the thing operator. By including the square brackets, the compiler is smart enough to destroy each object in the array and return its memory to the free store. To see this, change the size of the array from 500 to 10 on lines 25, 28, and 33. 25, 28, 33. Okay, so if you delete... Oh, damn. If you just do delete family and then brackets, it actually deletes all of them. Okay. Delete with the... If you use the delete with the operator by including the square brackets, it's smart enough to destroy each object in the array and return its memory to the free store. To see this, change the element to 5, then uncomment the cout. The array is destroyed. Each of these structures called. When you create an element on the heap by creating new, you always delete that item and free its memory with delete. Similarly, when you create an array using new, you could do this. You delete that array and free all its memory with delete. The brackets signals the compiler that the array is being deleted. If you leave the brackets off, only the first object in the array is deleted. You can prove this to yourself by removing the brackets and if you edit it. Congratulations, you just create a memory leak. Okay. Let's see. How much is this more? Okay. So, yeah, if you want to delete arrays from the free store, just do, let's say you allocate your array, right? New, whatever. You point it to a new array, right? You just do delete name of your thing with brackets, and that deletes all of the things in your array. It frees all the memory. So you could also resize arrays at runtime. The biggest advantage is the heap is that you could determine the size of the array at runtime and then allocate it. So you could ask the user to enter size of a family into a variable called size of family, and then you could then declare a cat array as follows. With that, you could now have a pointer to an array of cat objects. You could then create a pointer to the first element loop through this array using a pointer and a pointer arithmetic. So yeah. Because C++ uses no more than special cases of pointers, you can skip the second pointer and simply use the standard array indexing. Okay, so yeah. Okay, that's what they did. You could allocate array on the runtime. Yeah. All right, character arrays and strings. So there is a type of array that gets special attention. This is an array of characters that is terminated by null. This character is considered a C-style string. The only C-style strings you've seen to now have been unnamed C-style string constants used in cout statements such as hello world. You can declare a C-style string the same as you would declare any array. So you could declare a C-style string be charged greeting. We talked about this, okay? Hello, if I want to see out hello world, right? This string, literal hello world. What I have to do is create char greeting hello, each character space, then world, then a null terminator string, because each array for a string ends with a null terminator character. In this case, greeting is declared as an array of characters and is initialized with a number of characters. The last character /0 is a null terminated character, which many C++ functions recognizes as the terminator character for a C-style string. Although this character by character approach works, it is difficult to type and it admits too many opportunities for error. So C++ enables you the shorthand form of the previous code by doing this: char greeting equals hello world. So the thing you need to know about this syntax, instead of using single quotes separated by commas, you can have a double quoted style C string, no strings and no brackets. Okay, and no commas, no brackets. You don't need to add a null terminator because the compiler adds it for you. So remember last time we talked about this cat array of characters? They added a null terminating character 0, right? That's why we had to have the size of 4 to include the null terminating character. Because in C++ and C, they need to know when the length of the string, the end of the string ends, and it ends with the 0, null terminating character. So instead of doing this now, we could actually just create cat. And we don't have to include their size because it automatically knows it, and it automatically adds the null terminating character. Okay, so you don't need, you didn't make sure you enlarges the need. So this includes a null terminating character. You can also create uninitialized character arrays with all this demonstrates. Okay, so see add 80 buffer. Okay, so two problems occur here. First, if the user enters more than 79 characters, CN writes past the end of the buffer. Second, if the user enters a space, CN thinks it's the end of the string and it stops continuing to buffer. To solve this problem, you can use special met cn.get to get okay. Fill with an array with a maximum number of characters. Okay, so yeah, you can fill an array with the maximum of characters like this. Enter a string and do that. str copy and str end copy. So a number of functions exist which are available in C++ when dealing with strings. C++ inherits many of these functions for dealing with C-style strings from the C language. Among many functions provided are two for copying one string to another: string copy, string end copy. String copy copies the entire contents of one string into a designated buffer. The other string end copy copies a number of characters from one string to another. So this demonstrates a copy of string copy. Okay, so this copies the string. I'll type this out. So this actually copies the string. So let's just delete this. So if I create a string, okay, when I say string, a string is just an array of characters. That's what it is. It's literally just an array of characters. So what does this do? Copies everything from string 1, string 1, all the values no man is an island, into the character array 80. That's what it does. But remember, you need to have the right size. If you don't, it might not work. So this has 80 characters. So wait, okay, there's a few errors. Let me see. Okay, I'm getting error. This is just a warning. Okay, let's just run it anyway. They're saying don't use string copy, use... Oh my god. Okay, so my compiler is giving me a warning. Because they don't want me to use string copy. It's unsafe. Okay, whatever. Well, basically, this copies everything from string 1 to string 2. Source into destination. So this is really simple. It copies the data from string 1 to another. Yeah. Just be careful if the source is larger than the destination, it overwrites past the end of the buffer. When I say buffer, it writes past the null terminating character. To protect against this, the library includes string ncopy, and this takes a maximum number of characters to copy. String copies up to the first null character or the maximum number of characters specified in the destination buffer. So here's how they use string ncopy. So they have a max length of 80, right? Then they have a char array string 1, no man is an island, and then string 2, max length plus 1. So they copied the max length of 80 of the number of, so they copy string 1 into string 2, right? And they say, how many am I going to copy? Well, I'm going to copy 80 characters. That's what it does. That's what it means. Okay, I'm going to copy 80 characters from string 1 to string 2. Once again, this is represented. The maximum number is the buffer is declared in string plus 1, so extra cause no. Which both, okay, so string copy and string ncopy automatically adds the end of string for the null. So now we're going to talk about using the string class instead of using an array of characters. So remember I talked about that a string is just an array of characters, right? Like right here, except that it adds a null terminating character /0, right? So if I wanted to, if I wanted to declare an array of char, I don't know, cat, remember? A string cat. C-A-T. I have to include the null terminating character. So if I say 3, that's wrong, okay? Because I have to declare it to have 4. If I want to create cat, I have to have 4 to include the null terminating character, okay? This is just FYI for character arrays, if you're using character arrays. But you could also use the string class. C++ inherited the null terminating C-style string and the library of functions that includes str copy from C, but these functions aren't integrated into an object-oriented frame. So what they did was they created a C++ class that provides encapsulation sets of data functions for manipulating data, as well as accessors that are hidden from the class, the clients. So before using this class, you'll create a custom C class as an exercise to understand the issue. Oh, okay. Damn, okay, at a minimum, your string class should overcome the basic limitations of character arrays. So like all arrays, character arrays are static. You must define how large they are. They always take up that much room in memory, even if you don't need them at all. Writing past the end of the array is dangerous. A good string class allocates as much as memory as possible. Okay, so here they wrote their own string class. I'm actually not going to do that because that just takes way too much time. But you could do that. But here, okay. Wow, they actually wrote their whole string class. Okay, so I'll just tell you what the methods of string are. I'll just explain to you what this code is. Okay, so they want to create a string of objects, a string object, right? A string class, right? So what do? They need a constructor string. Well, the default constructor, they need to initialize it with like nothing, right? Empty string. If you don't have anything for a string, it should be empty. So what do they do for the default constructor? They created a they allocated memory for one character, and they just added an empty string /0, and then they set the length to 0, right? So what they have is the length of the string, a pointer to the first element of the string, and then they have the string, a character pointer, which is another name for a character array, right? In this case, and then a string unsigned short, which is a private constructor. So what they do is, in empty string, they allocate a memory for one character, then they set that character to 0. Null terminate character, because it's empty. If it's a null terminate character, that means it's the end of the array. It's empty. It's an empty string. So then they set the length to 0. Okay, so then they have a private helper constructor used only for creating a new string of a required size. So if it's given a size, they allocate memory for the length +1, and then they set them all to empty arrays, null terminating characters. So that means that they're all empty, okay? And then the length, they set it to length. So this is a constructor given if the user wants to have a required size, a string of a required size. They also have a thing where it converts a character array to a string, which is exactly what a string is. A string is a character array. So they put a constructor here. They get the length of str length gets the length of the character pointer, right? Then they allocate a memory for the whole string +1 for the null terminating character, and then they loop through everything, and then they set each value for the string, each character in the length to each character in this string to whatever character in the pointer. So character pointers are exactly like arrays. It's like in this case. So each they loop through every single. They get the length of their array of characters, right? Character array, right? Then they created the current string, right? The instance array of the allocate memory for our string, and then they loop through our string, and they set each one to the whatever value of the character array, and then they add the null terminating character at the end. Okay, so they also have a copy constructor given a string, and that just that gets a length, then it initially allocates memory for our array, and then it loops through every single array, and then sets each item to another item, and then it adds the null terminating character. And then they have a destructor that frees all allocated memory. Delete brackets its string. That frees all the memory in the array, and then set the length to 0. Okay, then they have an operator equals. Frees existing memory, then copies the string in size. So if you set something equal, they check if this is equal to that. If it's the same memory address, they just return the current data of the current object, right? And then they free it. Free the array. They get the thing. They copy each string to the new one. That's what they did. Okay, so this basically deletes the current string and copies everything into it. Okay, non-existing offset returns reference to a character so it can be changed. Okay, they overloaded the brackets. That's strange. Okay, so if it's greater than the offset, if it's greater than length, they return length -1 to the end of it. Okay. The end of the string, the last element of the string. Otherwise, they return the offset. Okay, so an offset is just, I don't know, the index. Okay, they overloaded this again, which is the same thing, except they use copy constructor. They made it const. Okay, overload the plus. Okay, this is concatenating two strings together. What do? They get the total length of each string. Then they created their own, the temporary string, calling their constructor. Okay, then they did allocate a length for it. Then they loop through every single item in the current array of characters and set it equal to the item of the array of characters of theirs. And they loop through it again, setting this time the next one. Oh, okay, I know what they're doing. Okay, so they're trying to, this adds the current, returns a new string by adding the current string to RHS. Okay, so what do? They created a string of, so let's say I want to add cat to dog, right? So what do? They find the length of cat and the length of dog, which is 6 plus 1. Oh yeah, it's 6, yeah, okay. Yeah, 6, and then they created a string of that. It's actually 7, including the null terminating character. They loop through from 0 to 3 that copies everything for cat into the thing, and then if you have dog, it copies the rest of it into the thing, and then they set the null terminating character, and then they return. Okay, so if you want to add two strings together, it's like concatenating it into an array. I'll just tell you what I'm talking about. So if you want to add cat to dog, cat dog, right? So what can you do? Well, okay, so let's say I pass in dog into the thing, into the function. So what I'm going to do, I'm going to create an array of all these, of 6 elements. 1, 2, 3, 4, 5, 6, right? And then what do? They loop through the, because you're given this array and you're given that. Because remember, strings are just array of characters, right? So you're given these two. These are separate array 1, array 2. So what do? They get the length of the total one, which is cat plus dog, which is 6. They allocated memory for the 6 plus 1, the null terminating character, because this is a string temp. They loop through from 0 to its length, which is cat's length, and then they set each element as this is temp, right? And there's like, okay, temp is equal to cat, CAT, from 0 to 3. And then they say, okay, from 0 to the length of dog, 0 to 3, they set temp at J. Wait, what? Oh no, but yeah, at J. So they're still adding I. So what do? They add I. So temp's I is 0, 1, 2, 3, right? So they keep adding. So then dog at 3 is the value at 0, right? And then because they added I plus plus, then J is 0, right? And then it's dog is 0, and then G. It's because they're saying, okay, from 0, 1, 2, loop through the array here, copy everything from temp. Then the index of I is now 3 because they added 1, and so then they're like, okay, add 3, set equal to whatever it's here. These are now equal. Okay, that's what they're doing. It's in the copy constructor. Okay, and in the plus concatenation, plus equals, it's the same thing, pretty much, except you're setting star this equal to temp. Here they returned a temporary thing. Yeah, that's all they did. What else do they have? Okay, so there are other data structures, which is like linked lists. We'll talk about that later in the data structures tutorial I'll give. But yeah, that's pretty much it. You could create your own array classes though. Writing your own array class advantages to build an array. So just remember that each member is in sort order: set, a dictionary, sparse array, bag. So yeah, by overloading this, you can turn a linked list into a okay. So summary, that's basically all what arrays and strings are. Rate, comment, subscribe. I'll check you guys later. Peace.